Today I'm gonna build a robotic arm. Fuck. Alright, I already fucked this up. Oh. This started about 2 months ago. First I made this soft robotic gripper. It's pneumatic, so you pressurize it and it closes. Then in my last video I designed the PCBs to control the pneumatics and the electronics. And the pneumatics just came, so I'm going to solder the PCBs and then I can finally start designing the robotic arm. Right, the soldering has been going well. Apart from these big parts, it's pretty much finished. And now I'm gonna be soldering this AMS1117. It's a voltage regulator. It steps down the input voltage to 3.3 volts. And it's an SMD component, so it's not through hole. You can't solder in from the back, you have to solder it from the front. And for this you need SMD soldering paste. It's gonna be my first time trying this out, so we'll see how it goes. I haven't googled how to SMD solder, but I'm just gonna wing it. I'm gonna put some flux on the contacts. Of course, I lost the back bar, so I'm gonna use this pen to squeeze the paste out of it. I'm not sure if I should put the paste before or after. Yeah, probably before. Peachy. I already spilled the paste and I also lost the AMS regulator. Yeah, this is not going too great. Oh, here it is. It's so small. Okay, now the heat gun. I think I'm gonna put more paste onto it. We're gonna see if it works. Alright, this is pretty much finished. I haven't put the capacitors in yet because I want to see what effect they have. If I don't need them, I won't put them in. And I haven't put the N-channel MOSFET here because I think I fucked them up. In the footprint editor I used the package for this specific MOSFET. The package had the pins labeled differently than the schematic, so it's fucked and I'm gonna have to probably twist the legs of the MOSFET to make this work. I'm gonna solder the controller and then we're gonna build the robotic arm. Yeah, I've got some buttons. Using these joysticks, and I was pretty scared it's not gonna fit because I honestly don't trust AliExpress datasheets. I modeled it with the provided dimensions and it fits perfectly. The controller is finished. I haven't soldered some of these parts, that's just optional if I use ESP, which I'm probably not gonna do. So it has 2 joysticks, potentiometer, LED light, and 2 buttons. By the way, if you're wondering where I got these PCBs, it's from my sponsor PCBWay. I've used them many times in the past for my projects and they are great. If you buy PCBs that are under 100 by 100 millimeters, you can get 10 of them for $5, and if you click the link in the description, you get a $5 coupon. Oh, and it's not just PCBs, they also do manufacturing stuff like CNC machining, injection molding and 3D printing. So if you need anything like this, make sure to check them out. Pretty sick. Since I went for a minimalistic design, the final assembly ended up being only about 120 grams of PLA. Now I'm going to attach the power stuff, so the power input from the LiPo battery, then the buck converter, and finally the switch. this is not going anywhere. Right, I almost forgot. For the buck converter, I need to adjust the output voltage because it's variable. The voltage is still there, even though I disconnected the battery. It's these capacitors just slowly discharging. 7 volts, I'm happy with that. Yeah, I just double checked the connections because this could all blow up if I switch these 2 wires. Now I'm going to attach the LiPo battery and hopefully it's not gonna burn. The LED is shining, that's good. The output voltage is at 7 volts, that's also good. I coded a calibration program for the Arduino, so it should move the servo motor at 90 degrees, I think. That's weird. Okay, the servo isn't moving, I don't know why. Oh yeah, I just realized for the calibration code I used the same code as I used for my hexapod, and the hexapod used a different Arduino, it used Arduino Mega, so the digital pins were labeled as like 20 to 40 I think, and the digital pins I have here are 10 to 13, so I'm gonna quickly change that in the code and it should work. Let's do it. I rewrote the code, now it should move smoothly. Nice. Since I have all the parts printed, I'm going to set all of these servos to their default position and I'm gonna assemble the leg. I've calibrated all the servos. These move 270 degrees, so I set the neutral position to half of that, which is 145. So this should be exactly at the half, but if you look at it, it's, I don't know, like 3 degrees off. This is pretty common. I could move it the 3 degrees back, so it's exactly at the half point. And this would also make the inverse kinematics in the future more accurate. This is gonna definitely cause an error that's gonna be seen by a human eye, but I don't care too much. It's just a first prototype. I might do this later. So I'm gonna attach these servos to the 3D printed parts and we're gonna see how it goes. And of course I'll be using my bolt organizer I built about a month ago. Alright, I already fucked this up. This is supposed to hold the bolts. They are supposed to be screwed into this servo arm. And I've added heatset inserts to this. So I'm gonna have to take them out quickly. This was annoying. I hope I won't have to do it again. This assembly is quite confusing, so I'm having to look at the Fusion 360 assembly to make sure I'm bolting the parts together correctly. By some miracle, this is actually mirrored. I fucked this up, so every single bolt I'm screwed in, I fucked up. So I'm gonna just disassemble it and start over again. Okay, this is finished. I'm gonna check how rigid this is. This is first prototype, it's super shit. There's some wiggle, but that's from the servo motors. Okay, the base isn't great. Yeah, it's about what I expected, maybe slightly better even. So I finished assembling the leg. I connected the servos to the main PCB. I'm gonna power this up. I think this will just all straighten up. Fuck. Okay. I designed this to be 2 separate PCBs. One is for the controls and the second one is the main PCB. These guys are gonna be connected with this long cable. It's kind of ugly and very thick, but I'm not exactly what you would call a perfectionist. Now I'm gonna write some basic code for these joysticks, and with them I'm gonna control the servo motors. Just a quick update, I wrote some code and I got all of the servo motors to move, but this servo motor for a gripper needs a long cable, so I added this additional cable to the servo cable, and I think this creates a lot of noise because if I try moving it, I mean it moves, but it takes a long time. It doesn't work as well as I want it to. So I'm gonna try adding these capacitors and we'll see if it makes it better. Otherwise I will probably solder these cables together so there's a higher quality connection. Alright, I tested it with the caps and it still doesn't work. So I think it's probably this connection. This pin header is poorly soldered. I just tested it on a different motor, which has the shorter cable, and it still doesn't work, even on a different motor. So I'm going to resolder this pin header. And otherwise, I think I can tell the effect of the capacitors, because the movements are smoother. So this is to be expected. I just wanted to make sure I'm not putting these caps up there for no reason. Alright, I finally figured out why this wasn't working. So when I try to move these two joints, it works fine, but these two have a problem that they just don't move. And I thought it's the electronics problem, so I went over the whole PCB, checked everything with a multimeter, and everything seemed to be fine. And I just found out this whole time the problem was the code. These servos move 270 degrees, and for example for the gripper this is the default position. So I'm gonna move the gripper now. If I move it this way, nothing happens because it's at the maximum position it can be at. And if I try to move it the other way, it doesn't move right away because the code thinks that the gripper is here, and when I tell it to move the other way, it moves, let's say here, which is still further than the max position, so it looks like it's not responding at all, even though the problem is just the wind up in the code. So I have to hold it for longer time, and then it starts to move, and it works fine. I'm gonna fix this in the code. I'm gonna saturate the max position so I can go over 270 degrees. There's another issue I just found out. These servos are supposed to move 270 degrees, but they don't. So right now it's done, so 270 would be somewhere here. And if I try to move this, it's about, I don't know, 30 degrees less. I just found out what was the problem. The library I use for the servo moment assumes that the servo's max angle is 180 degrees and writes the PWM signal accordingly. So these servo motors are controlled by a PWM signal. The servo.h library assumes that your servo is 180 degrees and it writes the PWM signal accordingly. So I wrote my own function, and now when I run the code, everything works as expected. So that was a nice little segue. I added this saturation function, so when you reach the max angle, it won't increase it, and this burns the wind up. And this is how it moves with the new code. So just look at this angle, or actually I'm just gonna hold it like that so it's easier to see. And it should move 145 degrees to each side. Oh. Nice. It's also pretty cool that if you move the joystick at 45 degrees, these two joints move at the same speed, so this angle stays constant. So I've been trying to pick up this tape with my robotic arm, because it's kind of boring to build it and not do anything. This gripper was meant to be just decoration and it slips, so I'm gonna add this heat shrink tubing and then I will be able to pick up this tape, hopefully. That fire wasn't expected. Fuck. As I said before, I fucked up the MOSFETs on the PCB. That's because in KiCad, if you just put a generic N-channel MOSFET in the schematic, the pins are labeled differently than in the footprint editor. So I just used the default settings and got completely wrong pins. So when I look at my own fucking video, this is an N-channel MOSFET, which means that the current should flow from drain to source and the conventional current, and that's what's happening here. So there's 12 volts which go through a pump and they flow into the ground. So the ground is gonna be at the source pin, and when I checked online, the source pin is the third on the right. So I'm going to check where I have the source pin. So this is ground. Okay, so the source pin is this bottom. This right pin is the source pin. And this bottom pin on the PCB is also the source pin. So if I orient it like this, the right pin is correct. And I need to flip the two other pins. So that's the left pin and the middle pin. So I'm gonna snip off the legs. That's actually much harder than I thought it would be. Yeah, these are not sharp at all. Yeah, okay. There's probably a much better way to do this, I just haven't figured it out. I mean, this is the first thing I've thought of. I actually resoldered it because I did such a terrible job. These two cables are now twisted, so I need to solder them on top of the PCB. And this pin, it's THT, so I'm gonna solder it from the back. And this is gonna be quite painful, I imagine. This is how I soldered it. It looks awful, but I checked for short circuits and I think it's connected correctly. I even turned it on by accident and it didn't burn up, so I'm gonna solder the second one right away because all of my soldering stuff is prepared and I don't want to clean it up twice. And then I'm gonna code it and check if it actually works. Doing this was super painful. I mean, look at my table. I actually write down how many hours I spent each day doing engineering and YouTube, and fixing these MOSFETs cost me 2 hours. Alright, I just wrote up the code, so I'm gonna test the controls, and if it doesn't burn up, I'm gonna connect the pump and the solenoid to it. So I've connected the two MOSFETs to be turned on by these buttons, and nothing is happening, which is good. So I'm gonna connect the solenoid to it. I didn't feel like soldering these pins, so I just connected the solenoid to the pump. Okay, something's definitely wrong. I measured what the MOSFETs were doing, and it turns out that when I press these buttons, the digital pins on the Arduino should be at 5 volts, but they were at 1.2 volts. And it was because I forgot to set them as outputs. So I did that in the code. Now I've measured it and it's at 5 volts, so it should work. You won't see it, but you should hear this guy click on. Yeah, This is the button that does nothing. And this is the button with the solenoid. Since I fixed the MOSFETs and they look like they're about to fall apart at any time, I'm gonna fill them with hot glue. Beautiful. Playing with this arm is a lot of fun, but it's just a prototype. If you look here, this is my pneumatics box. So I'm gonna add all of these pneumatics, and I'm gonna add this pneumatic gripper to the robotic arm. I will also probably make it a lot bigger because the gripper is quite large. And if you want to print this yourself, I've shown you how to make the PCBs, connect the wiring, and kind of how to write the code, so you can build it yourself. Or if you want to save some time, you can check out my Patreon, where there are all the files and it also supports the channel. I've already got a few supporters on Patreon and I really appreciate you.